Well, good morning. This is the part 3, I think, of the dumpster dive. So what I have today is a Stanford Research SR560 low noise preamplifier. These are fairly high-end pieces of gear. They're probably about 4K on the used market, I think. This was going to the dumpster, so I grabbed it. Not sure it's going to be terribly useful, and the reason for that is here, as you can see on the, let me show you, on the top of the unit, it says smoking bad, do not use. So given that, I think it's perfectly the opportunity to follow Dave Jones' advice and don't turn it on. Let's take it apart. Okay, so I have the screws out of it, but man, those screws were really locked in there. This one actually even stripped out, so I had to grab my trusty, what do they call it? The Grab-It? The Pro Grab-It. You should be able to see it here if I get it out of the light. Pro Grab-It, there we go. And this is a great little tool to go grab screws that have stripped out. So you just basically put your drill on reverse, clean up the area, then turn out the extraction and put it, turn the little bit around, put it into the screw and then run it and bring it back out. Anyway, we now have the unit pulled apart. So let's take a look at that. All right, before we get going, the drink of the day and where's my little pointy stick? The drink of the day is more of my grapefruit soda. All right, so let's take the top off. Okay. Oh, that's unexpected. I guess this unit, well, they clearly look like 12 volt, what are they, sealed lead acid batteries. So it must be designed to run on battery, which I guess is probably to make sure that you can use it without having to worry about ground loops or anything like that. So let's take, let's put down my pointy stick, let's take this guy out. Okay, and oh, yep, there we go. Hang on, put this down here. Okay, it's a fairly hefty weight. Okay, so this is the bottom of the unit. You can see the stuff there. Let's let's flip it over. Take a look underneath now. Man, I'm sure these things didn't come apart. So there we go. They were not lying when they said burnt. We have a little bit, they have a little smoking bad. Somebody's taken it apart to take a look at it. And they must have torqued those screws down, something horrid. All right, let's zoom in and see if we can show you what we see. Okay, let's zoom right in. You can see burnt there. And if I push that out of the road, you can see, yep, quite a bit of charring on there. Now, U703, let me take a quick look at the manual. I printed out component stuff, but I didn't print out the list of things. Okay, U703, this is a CD4013. It's just a dual flip-flop. That's very bad. Okay, so let's take a look. We can probably see that on the bottom too. Move that out of the road. Yep, there you go. You can see it on the bottom. Wow, it's like burnt. I'm going to just get my magnifying glass in and take a look at that. Look at those traces. It's definitely charred the crap out of the board, but and it looks like it's even melted some of the solder right out of the joint. Let me find where that is in our pieces of paper here. So, okay, here we go. Okay, so you can see that we've got the dual flip-flop there. And if we take a look at the piece that was burnt, again, we can see that it's up here and there's the notch. So these are going to be 14, 13, 12, and 11. And if we take a look here at that dual flip-flop, we can see that 11 is going to join to 9, which is unburnt. 12 comes over to, what's that, R701. And 13 comes over to R701. So it's C and B. So they must be, it must be the, oh, there it is there. It's a resistor pack. So we should be able to buzz out the things and see if the traces themselves are still good. Okay. So if we go in and that's 8, that's 9. So then we should be on, yep, so that trace is still good. 10 doesn't look, well, it's 8, 9, 10 should be good. So 11 should go to, oh, 11 should go to 9, so we just did that, yep. Yep, so 12 should come over here to one of the resistor points. Now let me see if I can get my, yeah, so it's coming to what's that, 7 there, okay? And then next one should come to the next one up. Oh, no, there we go. All right, so the traces still seem to be good there. Let's take a look and see about the power for that. So I would assume it doesn't list power on the schematic going to a particular thing. It just says that VCC is connected to VReg. And if I have a look at the, if you have a look at the thing, you can see VReg is up here, VCC is here. So I'm assuming that it's going to come out of there. So everything should be connected to that. So if we do a little bit of a, okay. So that's, okay. So I'm guessing that might be bad. So there might be some trace problem there. So now that goes off to U701. So 701 is going to be one of these things here. And in fact, now I look in there, I can see it. Let me put my meter down and tilt it up a bit, and you can get in there and, yep, and you can see if we have a look in there that that's all burnt out. Future Tony here. Just wanted to comment on something that I saw while I was editing the video. If you look at the image on the screen now, you can actually see that right next to U701, the voltage regulator, there is a blown component. And that component is C710. That's an electrolytic capacitor. And, sorry, C709, I think. Anyway, it's C709, C710 both work to provide unregulated voltage to charge the battery pack. So I'm guessing maybe that cap let go, and in the process of letting go, it flooded all the stuff across the voltage regulator, and that caused the failure. Or maybe the voltage regulator failure caused the cap to blow. I don't know, but clearly we'll need to pull that out as well and take a look at that and see if the regulator itself is dead. Anyway, I'll return you back to the video. I don't have that part. Well, I have that part, but I don't have the others anyway. So we'll still do a part 3 in a little bit. All right, back to the video. And if we look under the back here, yeah, so you can see just in there that something's gone horribly wrong with that regulator, and let's fried that chip. Now that regulator pin is pin 2, So let's see if we can, let's see if I can get in there. Okay, no. So pin 2 should connect to R709. Now, that is an LM, hang on, let me take a look. That's an LM350, I think. Okay, so let me check the, I can't get in to read on that. I think it's a 350, but let me, I can't get in there to read, so, but I think it's a 350. So let me check the manual and we'll see. Yeah, it's an LM350, so it's an adjustable jockey. So let's flip over and see if we can get in on that pin there. So let me zoom out. Okay, so we're picking up VCC there. So that seems to imply that those two components that were burnt out there, even though the motherboard looks a little, the PCB looks a little crappy, we might be able to just pull it out, clean it up, put it in, replace the voltage regulator, and then kick off. Now, I don't have an LM350T, nor do I have a CD4013BE. So I'm going to have to call end of the video here, and I'll go out and buy a couple of those pieces and then come back, and then we'll give this a change and see if we can get this thing to work. I wonder whether the failure was the voltage regulator dying or something fed into the voltage regulator. When we have the replacement pieces, we'll have a bit more of a poke, and we'll have to pull the board out and take a look. Anyway, I hope you found this interesting, and I'll see you in the next version.